Hello, and welcome to day 3 of the software engineering workshop TeensInAI AI Accelerator. Today, we're going to talk about testing. And we'll start with the standard boring definition. What is software testing? Well, it's mostly a process. It's there to evaluate the functionality of a software application to determine whether the developed software meets the specified requirements or not, and to identify the defects in order to produce a quality product. You probably have heard the word bug instead of defect, and that's exactly what we mean, is when something doesn't go according to plan. And that's a typical result of enforcing software testing and realizing there's lots of issues with the code. There is no such thing as perfect code. We try as much as we can, but at the same time, code gets more and more complex with time, and you need techniques and processes to help you test the software before it reaches the users. There's nothing worse than finding bugs at the user expense by them finding them rather than us. And so, I think the reasons for needing software testing are clear. Why do we need testing? Well, it saves money. I mean, there's an example here. In 1996, a software bug caused the bank accounts of 800 people to be given $920 million. You can imagine the bank wasn't very pleased when they realized that money transfer had happened because of a software bug. At the same time, it keeps us safe. We know of, this is just one example of many. China Airlines in 1994 killing over 200 people because of a software bug. It does create quality products. How many times have you not uninstalled an app because it was just buggy or was sluggish or it just looked rubbish? Well, that's exactly why we need software testing to make sure that a certain quality bar is met before it even gets out there. And ultimately, it results in customer satisfaction. A very good example here when BA had about 6 major outages in 1 year, which resulted in thousands and thousands of cancellations and delays, which meant that lots of people just were put off from flying BA again. There are 4 basic testing levels, and that basically means how close you get to the code to how high up you get. So the lower level test, which we will do some examples of later on in this session, is unit testing. That's generally written by software engineers, and it's basically to validate that a specific function within your code behaves as expected. So this is where you take your minimum amount of functionality and you write code to make sure that that functionality is correct. For example, if you were writing a calculator, your function that does the addition will need tests to validate that 2 plus 2 is 4 and 6 plus 2 is 8. It's that sort of level of code that you would write to validate a few examples of what your function is supposed to achieve to make sure that it does achieve them. The next level up is integration testing. And this is when you have a bunch of those functions all aggregated together, talking to each other. At that point, we're testing the interaction between those integrated components. We call them modules as well. And this generally involves quite a lot of code and produces huge amounts of tracing data that we can use to spot issues when you're putting systems together. The next level is actually system testing. That's when you have a complete system set up and you want to do a full end-to-end test. For example, you have a login interface where you enter username and password, then you create some sort of entry, you do some edits, you print out some results, and then you log off. You want to make sure that that full end-to-end functionality works, and that's what system testing does. And the next one, and the most highest level one, is acceptance testing, and that's where either the product owner or the customer does a full test of the full application end-to-end and all the different user journeys to make sure that we meet the requirements that we committed to deliver against. So as a software engineer, you get involved in testing from the beginning, as I said before, particularly with unit testing. That's the most common one where software engineers have to build those tests themselves. We call this Whitebox testing because you actually look inside the box and you know how the code works, and therefore you can write tests that cope with things like edge cases, which is where very, very different combinations of events may happen that trigger bugs that otherwise you wouldn't have known about. Generally, you try to catch those up as a software engineer, but if that fails, the QA engineers are great at actually breaking your own code. So watch out for that. There's plenty of testing frameworks out there, and we will see one example of that later on in this session. The framework varies by language. They normally apply to specific languages or runtimes. And so you will have test frameworks for Java, JavaScript, C, C Sharp, Python. All those different languages will have their own test frameworks. They all tend to have very similar structures, and they all work in a similar way, so it's very easy to move from one to the other. And then finally, there's this division, or there's two camps, two schools of thought in development. One is the test-driven development, which means test first, and then the test last development, which obviously means test last. And the difference here is whether you write the tests before you write the code or after you write the code. And we're going to see the pros and cons of both of those in a second. We have about 6 parameters or metrics we can use to actually compare TDD and TLD. Now, if you look at this table, I'm not going to read through the whole thing, but effectively it just shows you that TDD is more code heavy. You have to write more tests. It's more time consuming. It's harder to learn and harder to get into the framework, but it's actually much more beneficial long term. It will save you huge amounts of time in the future, and obviously it will catch a lot more issues than TLD does. TLD is a bit of an afterthought. You write the code and then you think you cover some test cases. You always invariably miss some, and then unfortunately users end up finding them for you, and that's not a very good place to be. And so even though TDD is a much bigger time commitment, it's by far the best approach. More and more tech companies are joining the TDD bandwagon, mostly because it's designed to cope with very large code bases, with lots of releases, with the ability to do quick changes, but also to automate the release process and make sure that effectively everything that goes out to production is tested before it hits users. And that's a great plus of TDD. TLD can achieve something like that, but it's nowhere near as straightforward, and because it relies on just the human working out what the problems are, you invariably end up with users finding your mistakes. So on that basis, why are we going to focus on TDD? And that's what the rest of this session is going to be about. Well, as I said, although it's harder to learn, it's a huge advantage if you're trying to achieve full automation. And by full automation, I mean you can write code and it'll be out in production within minutes, as long as it passes all the tests that it has to pass. In the old-fashioned way, we would write code and write code and write code, then write some tests, and then hope when we launch to production all that long time after having built the code that nothing will happen. With TDD allows us to do these very small incremental releases, which saves a lot of embarrassment when things go wrong. It's just the best way to build evolving products. It just means that you can have lots of releases out there. You can, again, using our source control that we learned yesterday, you can use methodologies to go back in time, fix issues, patch them, release them again. It just allows you that much more flexibility. It also caters for all team sizes, and it caters with the change of those team sizes as you go, because the code is self-documented by tests. When a new person joins the team, all they have to do is look at the test and understand the product, rather than just coming to a massive code base, which has no comments or no tests to back them up, which makes it very hard to understand, and it makes the new engineer's life very hard and takes a long time to become productive in that team. So TDD helps you make that much more seamless. And if ultimately we're here because we want to become entrepreneurs, we want to build products that people will love and millions of users will use. The only way that you're gonna get to that level of scale reliably is TDD. So here we're trying to set you up for success and for the future of becoming one of the new unicorns in the UK or wherever you are. And in that case, you need to understand TDD and how to apply it. So, how does TDD work? I'm going to show you a couple of slides. The first one is a bit more textual, this one that you're looking at. The next one will be a bit of a flowchart. But it's based on the principle we call red-green refactor cycle. So effectively, before you start to implement a feature, you should write a test for it. That's step one. And because you've written a test for it, but there is no code to back it up, the test will fail. And that's what we call red state. So the solution to a red state is to then write the minimum amount of code that you can to make the test pass. And that's the green state. Once the test is passing, you're onto green. Now, you've written some code, you have a test to protect you against making mistakes. Now you can actually put some effort in making that code as best and as efficient and as optimized as possible. And that's what we call refactoring. Once you refactor your code, you start making sure that it's as good as it gets. And if you have broken something in the process of doing that refactoring, the test will go back to red, and then so you have that protection that you didn't have in a more traditional testing environment. Now, if we look at that from a flowchart sort of position, you can see from the left, we start the process, we add a test to the system, we run the test, and then obviously we'll ask the question, does it pass? If it doesn't pass, which is the typical thing when you just first written a test, you have to change the code that backs that test up. And then you run the test again, and then you'll either get a pass or a no pass. If it's a no pass, you change the code again and keep on iterating until you get a test that's actually successful and green. If it does pass, then you go into the question, are you done with changes with your code, or do you have more changes? If you have more changes, you go back to the beginning, add another test, and keep going, follow the loop. If you're done with changes because you've reached the feature parity that you needed to hand over to your customer, then you're done, then you've reached the end of the cycle. So that's effectively the same as the red-green refactor cycle, but in a sort of more visual flowchart way. So now that you know the basics, we're going to go through a bit of a demo of how to use TDD in Python, how to think the TDD way, and how to solve a problem the TDD way. So before you get started, if you want to follow along, you should have already installed Visual Studio Code, but there is the link. If you haven't, you definitely need to install Python for this one. So please go to python.org and download the version for your operating system. And now we're going to go to the demo, and I'll see you on the other side. Hello, and welcome to the TDD in Python demo. We're going to cover both the concept of TDD and how do you actually think in the TDD way and build code that way, but also a little bit of how you do testing with Python, unit testing in particular. We will use the standard unit test library that comes with Python. There's all the third-party ones you can bring in, but for the purpose of the demo, is plenty powerful, and you can actually build proper code with it. And we're going to start with the premise that a customer has asked us to build a program that takes the user's first and last name, and it immediately renders it back out with proper formatting, as in the two words together with a space and proper capitals, etc. Now, because that's not what I'm trying to demonstrate here, I've already got a bit of a skeleton program that does that. It basically asks the user to enter their first and last names, or enter exit to exit. And then basically in an infinite loop, which is what that while true does, it'll constantly ask you for names, and it will ask you first to enter the first name and store it into a first name variable. If the first name variable actually happens to be X, it will exit the loop, which means it quits the program. Same with the last name. It will ask you for the last name. If you enter X, it will quit the program. Otherwise, it will store it into last name. And finally, we'll call this magic function called formatted name with the first name and the last name, and then print out the result of that function, which is the combined names with the proper capitalization. Now, that's all very well. Right now, we have a formatted name function, which does absolutely nothing. So it has the right signature, so it's called formatted name, and it has two arguments, two parameters, first name and last name, but it returns blank. Now, in true TDD style, the very first thing we need to do to make sure that we write the right code for the client, we need to create a test framework, a test suite, to be able to run our tests. Now, I've already put a little bit of skeleton here, which actually invokes or imports the unit test library within Python, and then actually runs it. When you do a run on this file, it will actually execute the main function of the test, which will actually go through tests. Now, the way that unit test and other libraries work is that you need to create what we call a class. Now, a class in Python and other languages, object-oriented languages, is a collection of data and behavior that are related to each other and that you want to self-contain or encapsulate into one single construct, and that construct is called a class. Now, the unit test library gives us a bunch of classes that do different functionalities. There's a particular one of interest called test case, and that's where you actually write tests and do different checks with them. So what you need to do to write a test class is to inherit from the base class test case. Inheriting means that you're basically taking on all the data and all the properties from the unit test case class, which means that you can just concentrate on writing your own tests and you don't have to do all the different bits that a test framework does for you. So let me show you how that's done. So I'm going to write a class called I'll call it names test case. And I'm going to inherit from unit test case, which is the base class that we want to inherit from. Now, in this way of creating classes for the particular unit test library, any function within this class that you write that starts with the word test will be run or executed as a test. So, for example, since we need to prove that our magic function is going to do what we think it's going to do, I'm going to create a function called test first last name. And now part of how you build it is you refer to its own class, which is self. And then effectively what we're going to do is I'm going to store in a result variable the results of the function. So formatted name is what we called it. Now realize that Visual Studio Code does not have a clue what this is at the minute. So what I need to add to this file is actually to bring in this name function, the formatted name, and that lives in a file called name function. So the way you do that in Python is to import. So we're gonna import from name function the file. I'm going to import the formatted name, and you can see that it's already read from the file class. And now this formatted name, there you go, now it knows who it is, and it has a first name and a last name argument. And so because I'm writing a test, I'm going to write a test that says Harry Potter as my first name, last name. And then I'm going to use one of the functions of the base class, which is assert. And if you think about assert, it's a way of validating unequivocally that something is true. In this case, I'm asserting assert equal that the result variable that contains the contents of my function, formatting function, matches what I expect it to do, which is to return Harry Potter in nice capitals and with a space in the middle. So if I do that, you can now run the test, which you can do straight from Visual Studio Code, and you'll see here that it's run one test and it's failed, and it tells us the error is blank does not equal Harry Potter. Now there's no surprise there because our function returns blank and not anything clever. So in true TDD fashion, and because I'm a software engineer, I've been told that in order to write TDD tests and then the follow-on code, you need to write the minimum amount of code possible for a test to pass. And guess what? The minimum amount of code that I can write is this. Right? So if I go back to my tests and I run them, what do you think is going to happen? The test passed. Now, that's all very well, but I am also a human being with a client, and the client has specifically told me that this function has to work for all names. And so the way to demonstrate that the code is not working properly is to effectively get this code, this test. I'm going to write another test, and I'm going to call it other. And this time, I'm going to change the name to Hermione Granger. You can see a theme developing here. There we go. And so the result I expect should be properly capitalized and with a space. So I'm saving that, I'm running the test, and hopefully, there we go, 2 test runs, 1 failure. Harry Potter does not equal Hermione Granger. Now, this is exactly what TDD is supposed to achieve. It's supposed to create a suite of tests that is sufficient to define the specification of the product that you've agreed to build. And so now we have a sufficiently large test base to actually tell us that in order to support more than one name, we need to do something else than just write Harry Potter here. And so I'm going to delete that. And now I'm going to do my refactor to go back from red to green. And to do that, I need to, start writing a little bit of real code. So I'm going to call a variable full name, and I'm going to make a combination first name plus a space plus last name, and then I'm going to return that, but because I want it nicely capitalized and with space in the middle, which is already done, I'm going to use the title function in Python, which actually, or the string property, which is actually going to make sure that things are capitalized as well as spaced. And so if I go back to my test now, and I run that, hopefully, if I didn't make any typos, there we go. Run 2 tests, they're all successful. So that's a good demo of how to go from red to green to red to green because of different test improvements. Now, the client is given us a call and he's told us, actually, you know what? There are certain cultures like the UK that use middle names, and we want your function to actually be able to cope with that situation. And so, we're at the end of the sprint, we're preparing the next sprint, and we say, okay, let's work out what it takes to make that happen, and then assign it to one of the developers. And one of the developers has gone away and said, okay, I'm going to make that happen. But because he's a TDD developer, guess what? The first thing he's going to do is write a test. Surprise, surprise. So let's write the test. Let me just make sure I have the right things here. And I'm going to call it test because I need it to be a test, executable test. And then I'm going to call it first, middle, last name. And then, of course, the standard constructor. And then I'm going to say, okay, I'm going to make the function, formatted name. But you realize the parameters that formatted name supports are first name, last name. Now, because I'm a software engineer and I love backwards compatibility, and I want my function to continue to support what he did support before whilst enhancing it, instead of actually doing what you may think maybe the logic thing, which is to actually change the parameter list to first, middle, and last, I'm going to return first and last and add middle as a third parameter. So my test is going to check someone that has a middle name. So Albus Potter, first name and last name, and then middle name Severus. And then I'm going to do my standard self assert equal. We'll compare the result variable with what we expect, which is Albus Severus Potter. I was going to write snake for a second. Save that. I'm going to run our tests. And I expect that there's going to be a failure, and it's a compilation failure. See? It's not a failure on the function itself. It's a failure on the format or the signature of the function. It's telling me that my function has 2 parameters, 2 arguments, but I've asked for 3. And so what it's telling me is that, okay, you've added a new requirement to the program. Now you're going to have to go and update your function to support that. And so that's what we're going to do. I'm going to go to name function. I'm going to add a third parameter. Oops. Inside the brackets, there's middle name. If I can type today. And then, because I know that some people are not going to enter that parameter because of backwards compatibility, I'm going to give it a default value of blank. So if you don't type a third argument, it will be blank. And because it will be blank, the first thing you need to do to update this code is to check for that. So I'm going to say if length of middle name is greater than 0, then I'm going to construct a new full name that will include my first name and a space and a middle name and a space and my last name. However, if there is no middle name, then I do what I did before, because the code doesn't change. And the full name title is still the same, because all it does is capitalizes every word within the string. So let's go back to our test. Let's save this again, and you'll see that, it's no longer red, because now formatted name has the right number of parameters. So let's go to the tests, run them. look at the terminal, and there we go. 3 tests, 3 tests passed. So now we have a function that achieves all the requirements. It supports any combination of names, and it supports a middle name. Now what we don't have, it's a program that can implement this functionality. So as a final step, we're going to go in here, and we're going to add the functionality. And because I'm lazy, I'm just going to copy one of these, paste it here, change that to middle name. And I'm going to say, please enter middle name. And if it's X, then I'm going to exit the same as the others. But if not, it's going to be stored there. And so the last thing, of course, see your parameter list there? So middle name is actually the third parameter. So if I save that, and we now execute this program rather than the tests, we should see, there you go. Please enter the first and last names or enter X to exit. So I'm going to say Albus, middle name Severus, last name Potter. And the formatted name is Albus Severus Potter, with the spaces, with capitals, as we hoped. Now, I don't want to write any more names, so I'm going to type X, and that ends the program. So now we have what the customer asked us for in those 2 stages. We have the program that can read first, middle, and last name, and it can format it nicely as expected with a full suite of tests. That means that if we do change this code, or if we do change the function, the tests will break. And if they break, they're a good sign. That means that we're going into the red-green refactor cycle. So I hope you enjoyed that. I hope you learned enough about how TDD works. This was mostly about teaching you the principle of test first, meaning you have to write tests, then write code to comply with those tests. And this will give you a much bigger longevity, resilience, and it will make maintenance of code base so much easier in the long term. It's worth the time investment, believe me. This is from a professional that's been doing it for many years and scaled into big products that did massive benefit from having this large number of tests. Also, we saw how to write unit tests in Python, particularly using the unit test library. You've now learned a little bit about classes, a little bit about how you do asserts, and there's all sorts of asserts, not just equal, but there's assert, not equal, greater than, less than, all those sorts of things. Now you know how to construct code, test it, and validate that you have the right results. I hope you enjoyed that, and I'll see you in the next slides. Great. Now that we've done the demo, let's go to today's challenges. So for today's challenges, I'd love you to read some more on TDD. And there's one link, there's loads of them in Google. Feel free to choose the one that you like the most. Then I want you to do a little bit more investigation as to how to do Python testing. For that, I've given you the link there for the actual unit test library, but feel free to Google other frameworks if you feel that you want to learn other frameworks. They all look very similar, so go ahead and have a go. And then as the actual doing challenge, I'd love you to pretend that the customer has asked you to enhance the formatted name function to do a few more things. You tell me what those are. It could be supporting other languages, or it could be supporting the order change to last name, first name, things like that. How would you solve that with the TDD approach? What test would you write? And would your code compile and succeed, go green with those tests? Have fun trying, and let me know if you have any problems in the questions with the mentors. And that's it. I hope you enjoyed day 3, and we'll see you for the final 2 days where we actually build some code. Bye.